Before we talked about the definition of inverse functions and what they look like graphically, today we're going to talk about how to tell things about inverse functions algebraically, specifically how to find an inverse function and how to check that two functions are actually inverses. So first, to find the inverse of a function, you're going to replace the x and the y, switch them, and then solve for y. So let's take this function. We have this. We're going to have to restrict the domain to actually find the inverse of it, but that'll be okay. So y equals 3 times the cotangent of x minus pi over 4 minus 20. We're going to have to switch the x and the y. So x equals all that with y minus pi over 4. Now, let's solve for y. Move the 20 over to the other side. Then divide by 3. Now, we have to know the inverse function of cotangent. Now, this function isn't invertible until we restrict the domain, because if you remember, cotangent doesn't pass the horizontal line test. But you can force a function to pass the horizontal line test by restricting its domain. So we're going to take arc cotangent, or inverse cotangent, and lastly, we got to get y by itself, so we're one step away. Add pi over 4 to both sides. Arc cotangent of x plus 20 over 3 plus pi over 4. All right, so that is how we find an inverse function of something. Let's try another. If we take the inverse of this, we have to switch them. So we have x equals e to the y squared. Well, what's the opposite of raising something to a power? Taking the natural log of both sides. So take the natural log. I'm going to write this out the long way. So natural log of e to the y squared, which is the same thing as y squared. Lastly, again, we're going to take plus or minus the square root of both sides. This is, again, a case where I picked something that was not actually invertible, because there are multiple pieces to this. You have to pick one piece in order for you to get an inverse. So maybe this question and the previous question would be better described as find an inverse of g of x. So here is one of the inverses of this function. How do we tell that two functions are inverses? Well, let's go back to the definition. Two functions are inverses if and only if you plug one of them into the other and you get out x both times. So if both are true, then they're inverses. So I have these two functions. How do we check that they're inverses? First of all, let's figure out what fog is. So fog of x is, we're going to take the 5x plus 3 over x minus 1 and substitute that in to f of x. Now, getting a common denominator here, 5x plus 3 plus 3x minus 3 all over x minus 1. over 5x plus 3 over x minus 1 minus 5x plus 5. So what I've done is I got a common denominator of x minus 1 here by multiplying this by x minus 1 over x minus 1, which is how I got the 3x minus 3. Same thing here, multiplied by x minus 1 over x minus 1 gives us the negative 5x plus 5 and the x minus 1 in the denominator. We can simplify this and say the numerator is 8x over x minus 1, and the denominator is 8 over x minus 1 using our fraction division. This is the same thing as x minus 1 over 8. Those cancel, and we are left with x. So far, so good. Now we have to do this again, but instead of looking for whether fog exists, we have to, or is x, we have to see whether gof is also x. So gof of x, again, we're going to use our composing functions. We can take 5 blank minus 3 over blank minus 1 and substitute in f of x. X plus 3 over x minus 5, x plus 3 over x minus 5. Get common denominators. I'll write it out the long way this time. 5x plus 15 over x minus 5. The common denominator is x minus 5, so 3x minus 15 over x minus 5. In the denominator, we get the common denominator of x minus 5 again. Key step here is to remember to distribute those negatives. So we have 5x plus 15 minus 3x plus 15, because we have to distribute this negative. Just a note on distributing negatives to fractions. I think you already remember this when we had negative 3 halves or something like that. It's negative 3 divided by positive 2. Same thing here. You distribute the negative just to the numerator and not to the denominator. So this is all over x minus 5. And this is x plus 3 minus x plus 5 over x minus 5. Now simplify the numerator. The numerator is 5x minus 3x is 2x. 15 plus 15 is 30 over x minus 5. In the denominator, we have 8 over x minus 5, which isn't working out. That will give us 2x plus 30 over 8. So that looks like they're not inverses. Did I make a mistake? Yes I did. See, in the original problem, I did 5x plus 3, but here I wrote 5x minus 3. So this should have been plus, this should have been plus, and that changes when we distribute here. We should have had plus 3x and plus negative 15. Okay, so now that we have those correct, this should be 8x there, 8x, and positive 15 minus 15, that becomes 0. So now we have 8x. Oh, this is working out a lot better. We have 8x over x minus 5 divided by 8 over x minus 5. That is going to end up being x. So, a little bit of losing track of a sign made an error, but when you check your work, you can find out those things quite reasonably. So this is again how to determine whether two functions are inverses. Find fog, find gof, and if they are inverses, they'll both end up as x. Thanks.